Hello, welcome back. So we're now moving on to the scenario analysis with probability distributions because the portfolio fund management example we did in example 5.1, I believe this is table 5.1. Is a very static picture. In other words, what I'm trying to say is there's no, if this is a past, right? I mean, the past is already done, right? Past is already, we have a indisputable data, indisputable record of the past. So it's not a difficult thing. I mean, most accounting procedures, are mainly, based on the past data. I mean, even the most recent one is already past. So calculating what is the quarterly return, or holding period return. In this example, holding period is 1 year. Of course, each quarter is holding period, because after each quarter, we calculated the funds, capital gains, the growth rate, and holding period return, or rate of return quarterly, and then eventually we annualized it, right? But it's all based on the past. But in investing, I mean, in finance, the main difference between finance and accounting is that finance is all about future, because finance is what's already past is past. There's nothing we can do to exploit some profit opportunity from the past, right? But finance is about making exploiting profit opportunity from future cash flows by investing in select assets. Now, therefore, we would want to basically, if we put $1 million into this fund, right? We want to forecast what's going to be the return on investment in this portfolio, from this portfolio. Now, so obviously the portfolio will have to, we'll have to figure out how the economy is going to turn out to be, because this future, we don't know how it's gonna turn out. So it is quite rational to devise 4 possible scenarios. I mean, the economy can be, normal, right? Most likely, normal growth. Economy may go through normal growth, which would have the highest probability. It may also go through mild recession, right? Which would have slightly lower probability than the normal growth. Boom, it can go through, economy can undergo a boom, which would have also, some probability, but obviously lower than normal growth. Or, there could be a severe recession. And 4 possible scenarios, and with each of them with some probabilities assigned. And of course, severe recession would have very low probability, right? All of them. So we will need we will need, a probability forecast. How do we probability forecast is generally obtained through Monte Carlo simulations. I mean, sometimes, the experienced fund managers, a gentleman call, right? It's not scientific, but in reality, experiences, give them some kind of feel about, how what would be the chances of, good economy or bad economy, severe recession, normal growth, this type of, but relying on that is not science. Relying on, although I give some credit to experienced fund managers, gut feeling, right? I can't say, I can't call it any more than, I don't think there's any better word than just gut feeling. But that's why it is not a science, right? They always say, I have experience, I have 20-year experience in fund portfolio management, investment banking, fund management. Look, some people are very good, right? And I admit, some fund managers have that animal instinct almost, but not everyone can be, if everyone, all the fund managers, just because they are seasoned, just because they have 20 years experience, 30 years experience, they won't be, they can't, their forecast, cannot be, a 10 out of 10. Still, I mean, it's less than, the odds are, less than, less than 4 to 6. In other words, their correct, accurate, forecast is not more than, 40%, right? I mean, 40% is still very, very, high probability. Most likely, 25, less than 25%. And if they are, getting 25% right, still, that is very high probability for gut feeling. So we don't, we generally follow, Monte Carlo simulation, Monte Carlo studies, and from Monte Carlo simulation, the probabilities will be, assigned, and which follows normal distribution. And if it follows normal distribution, the probability won't be exactly like this, but this is just a randomly assigned probability. I mean, just for the thought experiment. So if we have that kind of probability, then so think about it. If the holding period return, I mean, quarterly or annually, in an economic boom, you have 30%, return is, 30%. Your portfolio's return is 30%. Normal growth, 14%. A mild recession, -11%. Severe recession, -37%. So we need to get the weighted average of this. Make sense? Because what would be the most likeliest, what would be the likeliest, outcome? So what's going to be the portfolio's return? Well, the portfolio's return will have to be weighted average. And this is something, you learned from also Finance 100. If you have a portfolio, the portfolio return is the weighted average of um, uh, weighted average of each individual assets return, right? Of course, in this case, we don't have, but that was that example in Finance 100 was not scenario. I mean, we have stock XYZ. We selected, through a security analysis, we found three let's say three stocks, three assets, X, Y, and Z, and their expected return, is obviously three highest expected, three highest of all the stocks you from your analysis, you pick them, and then you allocate funds across these three assets. Of course, that's not the only concern. The other concern is their standard deviation, right? So, but in Finance 100, we didn't think about the possible scenarios of the economy. Now, in this example, we don't we ignore what kind of assets we have. I mean, this is just portfolio's weighted average of, if the portfolio has three assets, right? The weighted average of those three assets under boom is 30%. Under normal growth is 14%, right? And so on, right? This is basically that the portfolio with asset allocation, and then weighted by possible scenarios of the economy, possible four possible scenarios. So we already know that the expected return, this is portfolio return basically, is I should probably P for portfolio, right? The expected return is the mean of the distribution, or that's the average of weighted average. So it is the sum of probability times return on each individual asset. And individual assets run from 1 through n. So if n is 3, right? If n is 3, right? I would be that means you put money into 3 assets, right? Okay. And then in this case, these are here. This is already a portfolio return. This is already with 3 return on the portfolio with 3 with n assets, right? And this one is possible scenarios. Actually, I in this case is the so this is not individual asset. This is portfolio, right? Return, and then I represents individual incidents, incident, right? Incident meaning like boom, economic boom, normal growth, mild recession, and severe recession. So individual incidents, and they all have probabilities, right? And then portfolio returns under each scenario, right? And so that's weighted average, right? and the variance because variances and a standard deviation are basically the risk, right? The variability of portfolio returns. So we calculate variance this way, right? Or of course, in our scenario, because there are 4 instances, right? Also, we can, this is how it is expressed in probability, right? When we, weight it by the probabilities. Okay. Basically, this is, the difference terms, right? Squared difference terms and probability, right? You have, so this is, I, okay, actually running from, should actually, what is expressed as S here is, in other words, I, right? S would probably, they used S in this notation as the notation in this expression, probably to refer to specific instances, right? Specific instance. But it really doesn't matter. So we're gonna replicate, this exercise. I mean, under these 4 scenarios, right? The expected return from the portfolio is 10%, and the variance, the variance. This is not percentage. This is, this would be like 0.347. Standard deviation in percentage, 18.63. So that will be the variance, standard deviation, and the mean return of our portfolio, right? Which is the weighted average of all, the probabilities of 4 possible states of the economy, right? 4 possible scenarios, right? So, how do we get to this? Let me switch to. Well, so we need to. I have basically, replicated that spreadsheet 5.1 scenario analysis here in a file named AKM chapter 5 and 6 exercises 0, right? You should know. You can find it in our lecture notes folder, right? Course materials and this topic, right? So basically, this is a weighted average, right? What we want to do is find weighted average, and weighted average is basically weighted by the probabilities of these scenarios, right? So our expected return on the portfolio, once again, this is portfolio, right? Expected return. So I don't have to write P here, but you should already know this is about portfolio, right? And so portfolio return, right, is a sum of probability of these specific incidents or instances, right? And then the holding period return in that scenario or in that instance, and then that will be the expected return on the portfolio, which is exactly the weighted average, right? Weighted by the these probabilities. So let me. So basically, probability is 5%. Probability of severe recession is 5%, and then the return, expected return under severe recession is negative 37. So all you need to do is weight the probability, right? Weighted by the probability, and the rest of them are the same. You don't have to do, you can just copy and drag it down, and everything formulas are all right. And then the expected return is the sum of all of those, P times R, right? So all I need to do is just, use auto sum, should come to 10%. Let me use 2 decimal places by default, right? Always, keep in mind at least 2 to 3 decimal places, right? By default. And then once we find the mean return, which is the expected return of this portfolio, we need to find the variance of this portfolio. And to find a variance, we'll first have to take the difference terms, right? Difference terms are basically, what? Each individual scenario return, or return in each individual instance or scenario, and the difference from the mean. That's that's the definition of deviation, right? And then here we'll have to lock this, right? Because I'm gonna every time it's gonna be repeated. D12 will be the same. It's only the C, the column C that will change, right? Rows in column C that will change, but our mean will always be, will have to be in D12. So I have to lock it. I will lock it because I'm gonna copy, right? I'm gonna copy and paste. And there you go. And then what is variance? Variance is also variance of, of course, R, right? Variance of our returns, which are, basically also the weighted average, right? Of individual, first of all, probability of I times, each, individual scenario I, or individual instance, mean return, right? Drawing this is really difficult. Squared, right? I should do a better. My freehand is really not the most talented, right? I'm not that. The freehand is not talented. What can you do? Okay, that looks better than before, right? At least, you know, and so here's the probability, right? Times. We already have this, right? We have this, you know, difference term. We all we need to do is simply square it, right? Simply square it. Now I already put it as, you know, percentage. So as I drag it down, we get this, and then sum of all of that using auto sum, right? We'll get this. It's like 3.471%, and in the slide, it is, you know, they didn't put the percentage. They didn't put it into percentage, so it comes out like that. Now the standard deviation is the square root of that. So all you need to do is simply point to this cell, which is, you know, normally I would click it in, but this time, you know, my selected cell is even, you know, overshadowing or over, you know, hanging above. It's overlapping that cell, so I can't click it in. So I will just type it in. That will be, you know, F12. And then what is the square root? Square root is, you know, raising to half power. Okay, this is one way, and then you click, and this is what you get. And then another way of doing that is SQRT. That's the symbol for square root. And then that's the command for square root, right? There you go. Okay, so we got this. Okay, and let's go back to the slide. Let me stop sharing this and share. And you should be able to see this just about now. Okay, so yeah, check out the result, right? We got the same result, right? 10% expected return, or the expected, in other words, you know, weighted average, you know, mean value of mean return of the portfolio, and then standard deviation of the portfolio, 18.63%. Now, just one more thing. I have noticed that while I was, you know, explaining about, you know, like 10, 15 minutes into the video, the screen kind of got stuck. And although I rewinded, I went back to this slide, and the screen was still stuck on this on this slide, and then as I was explaining, this part, what is the weighted average by, how weighted average is expressed, with probabilities, and how, variance is expressed with probabilities. And this part, as I was explaining this part, it was all gone. I mean, it was stuck in this slide, so we couldn't correlate it probably with this slide. So let me quickly go over this again. So as I said, I refers to individual, right, or incidental. I mean, this incident, right, or this instance, and our scenarios are severe recession, mild recession, normal growth, normal economy, right, or good economy, boom, economic boom. All those scenarios are instances of the economy, right? So I represents each instance or incident, instance or incident. In this context, they all mean the same thing. Scenarios, right? And then because we have 4 instances, right? So in our example, I would run from 1 through 4. And then in variance, this is normally the way you calculate the sample variance, right? This one would be sample variance. This is, when we have no probabilities associated with each instance, right? But, if we have probabilities, think about it. Ignore this negative -1, but, if it is n, what does that mean? We're dividing by 4, right? Because we have 4 instances. And what does that mean? Every instance is weighted the same. If you're dividing simply by 4, that's like simple average, right? In that case, every instance has the same weight or same probability, right? If you divide it by 4, the probabilities are all the same, 25%, 25%, 25%, right? But then when probabilities are different, you can't do it like that. You will have to weight them by the probabilities of each instance, right? Or scenario. They used, S here originally, which would refer to specific instance or scenario, right? Again, the probabilities are like, the proportions, of proportion of weight, right? And they have all different proportions. So this is, how you find the variance, right? When probabilities are assigned. And of course, I don't have to go over, that's redundant because we already did it by Excel, right? Now we did it already by Excel, and we did it exactly like that. So there's no more, need to talk about that. Okay, so that's it for now. I'll see you guys in the next video. Stop recording.